Ah, the Chengdu J-20 Mighty Dragon, truly a remarkable aircraft. It's China's most advanced stealth fighter jet, designed and built by the Chengdu Aircraft Industry Group, which is part of the Aviation Industry Corporation of China, or AVIC. This aircraft marks a significant leap for China's aerospace industry. You see, it's a twin-engine, all-weather, fifth-generation fighter, primarily designed for air superiority, meaning it's built to control the skies. But hey, it also possesses precision strike capabilities. The nickname Mighty Dragon reflects its perceived power and China's ambitions, and its emergence has certainly caught the attention of global military analysts. Now, fifth-generation fighter jets are defined by several key characteristics. Stealth technology is paramount, making them difficult for enemy radar to detect. Another feature is supercruise, the ability to fly at supersonic speeds without using afterburners. Advanced avionics, including sophisticated sensors and data fusion, are also essential. These jets operate in a network-centric environment, sharing data with other friendly assets. The J-20 has been developed to embody these advanced traits. It represents China's dedicated effort to close the technological gap with other major air powers. This aircraft is, without a doubt, a symbol of national pride and technological achievement for China. The J-20 undertook its maiden flight on January 11, 2011. This event was a surprise to many international observers because, well, the speed of its development program was faster than many had anticipated. The People's Liberation Army Air Force officially inducted the J-20 into service in March 2017, making China the second country in the world, after the United States, to field an operational fifth-generation stealth fighter. The J-20 is a large aircraft, characterized by its long and wide fuselage, featuring a distinctive canard delta wing configuration. These design choices contribute to its aerodynamic performance and internal capacity. Understanding the J-20 is crucial for several reasons. It provides insight into the evolving landscape of global military aviation. The aircraft is more than just a new piece of military hardware. It signifies a major shift in technological capabilities and strategic intent. For China, the J-20 is a cornerstone of its military modernization program. It aims to enhance the PLADAF's ability to project power and defend China's interests. The capabilities of the Mighty Dragon are continuously being refined, and its ongoing development ensures it will remain a significant factor in air combat considerations for years to come. Stealth technology, now that's a defining feature of the J-20 Mighty Dragon. This capability aims to reduce an aircraft's detectability by enemy sensors, primarily radar, which stealth seeks to counter. The J-20's airframe incorporates specific shaping to achieve low observability, including aligned edges and blended surfaces. These design features are intended to deflect radar waves away from the emitting radar source. Instead of reflecting signals directly back, the J-20's shape scatters them, significantly reducing the aircraft's radar cross-section. A smaller radar cross-section means the aircraft appears much smaller on radar, or not at all. The materials used in the J-20's construction also play a vital role in its stealth. Advanced composite materials are used extensively throughout the airframe. These materials are lightweight yet strong, but more importantly, they can absorb radar energy. Radar absorbent materials, or RAM, are applied to the J-20's skin. These materials convert radar wave energy into heat, further diminishing the radar reflections from the aircraft. The careful selection and application of these materials are critical, complementing the airframe shaping to minimize its overall radar signature. This comprehensive approach to signature reduction is key to its stealth performance. Internal weapons carriage is another crucial aspect of the J-20's stealth design. External stores, like missiles and bombs, create significant radar reflections. The J-20 features large internal weapons bays, allowing it to carry its primary armament inside the fuselage. When weapons are deployed, the bay doors open briefly and then close, minimizing the time the aircraft's stealth is compromised. The main weapons bay is located on the underside of the fuselage, while smaller side bays likely house short-range air-to-air missiles. This internal carriage maintains the J-20's sleek, radar-evading profile during combat missions. Other details contribute to the J-20's low observability. The engine air intakes, for instance, are carefully designed, using diverterless supersonic inlets, or DSI. These bumps help to shield the highly reflective engine fan blades from radar waves. The engine nozzles are also an area of attention for stealth. Early J-20 models used conventional round nozzles, but newer versions appear to be incorporating serrated or sawtooth edges on the nozzles. These features help to reduce the rear aspect radar and infrared signature. Every detail from the canopy to access panels must be considered to achieve effective all-aspect stealth. The J-20 shows a clear commitment to these principles. The J-20 Mighty Dragon is equipped with a suite of advanced avionics and sensors, providing the pilot with superior situational awareness. A key component is its active electronically scanned array radar, or AESA. AESA radars offer significant advantages over older mechanically scanned radars. They can track multiple targets simultaneously and are more resistant to electronic jamming. The J-20's AESA radar, believed to be the Type 1475 or KLJ-5, is housed in its nose cone. This radar allows the J-20 to detect and engage targets at long ranges, providing the pilot with a clear picture of the surrounding airspace. In addition to its powerful radar, the J-20 employs an electro-optical targeting system, or EOTS, typically mounted under the nose, similar to the F-35 system. This sensor provides passive detection and tracking of targets using infrared and optical sensors. This means it can identify targets without emitting any radar signals itself, which is very useful in maintaining stealth. The EOTS can also provide targeting information for air-to-ground munitions, enhancing the J-20's versatility for different mission types. This system gives the pilot another way to see the battlefield. The J-20 is also thought to feature a distributed aperture system, or DAS, using multiple infrared sensors placed around the aircraft. These sensors provide a 360-degree view of the surrounding environment, detecting missile launches, approaching aircraft, and ground threats from any direction. The information from these sensors is processed and displayed to the pilot, significantly improving their awareness, especially in complex combat situations. It can also cue countermeasures automatically. This kind of spherical coverage is a hallmark of advanced fighter designs, helping the pilot see everything around them. All the data from these various sensors must be managed effectively. The J-20 utilizes advanced data fusion algorithms, combining information from the radar, EOTs, DAS, and other systems. They present a unified and coherent tactical picture to the pilot, reducing their workload and allowing them to make faster and better informed decisions. Network-centric capabilities are also integrated, allowing the J-20 to share data with other aircraft, ground stations, and naval assets. This collaborative approach enhances overall combat effectiveness. The J-20's brain is as important as its stealthy brawn, processing information very quickly. The J-20 Mighty Dragon's performance is heavily influenced by its power plant. Initially, an interim engine solution was used for prototypes and early production aircraft, reportedly Russian Saturn AL-31FN engines. Later, Chinese-developed Shenyang WS-10B Taihang engines were fitted to some J-20s, representing an improvement in thrust and reliability. However, China's ultimate goal is to equip the J-20 with the domestically produced Xi'an WS-15 engine. The WS-15 is designed to provide significantly more thrust, which is crucial for achieving supercruise sustained supersonic flight without afterburners. Supercruise is a key performance metric for fifth-generation fighters. The aerodynamic design of the J-20 contributes to its agility and performance. It features a long blended fuselage with a delta wing, and prominent canards located near the cockpit. Canards are small forewings that can improve maneuverability, especially at high angles of attack. They can also help with trim and lift. The J-20 also has twin all-moving vertical stabilizers and ventral fins. This combination of control surfaces suggests a design optimized for both speed and agility. While it is a large fighter, these features aim to give it impressive handling characteristics across its flight envelope. The precise level of its agility compared to Western counterparts is still debated by analysts. The J-20's large size suggests a design emphasis on range and internal fuel capacity, allowing it to conduct long-endurance patrols and deep penetration missions. A significant internal fuel load is necessary for sustained operations, especially if supercruise is employed. The ability to project air power over long distances is a key strategic requirement for the PL-8AF. The J-20's design seems well suited for operations over the vast expanses of the Western Pacific. Its range, combined with its stealth, makes it a potent platform for challenging an adversary's air defenses, traveling far without needing to refuel frequently. While the J-20 is undoubtedly fast and designed for high-altitude operations, its dogfighting capabilities are a subject of discussion. Some analysts suggest its large size and current engine limitations might make it less agile in close-quarters combat compared to smaller fighters like the F-22. However, modern air combat often emphasizes beyond visual range engagements. In this arena, the J-20's stealth, advanced sensors, and long-range missiles are more critical. As the WS-15 engine matures and becomes standard, the J-20's overall kinematic performance, including thrust-to-weight ratio and sustained turn rates, is expected to improve significantly, making it even more formidable. Section 5. Lethal Talons, the J-20's weapon systems. The J-20 Mighty Dragon is designed to carry a formidable array of weaponry. A key aspect of its fifth-generation design is the internal carriage of these weapons. This is essential for maintaining its stealth characteristics. The J-20 features a large main weapons bay located ventrally, between the engine intakes. This bay is believed to be capable of carrying at least 4 and possibly up to 6 beyond visual range air-to-air missiles, or BVE rams. The primary BVE ram for the J-20 is the PL-15. This missile is a long-range active radar-guided weapon. It is considered a peer to the latest versions of the American AIM-120 AMRAAM. In addition to the main bay, the J-20 has smaller side weapons bays. These are located on the sides of the fuselage near the engine intakes. These bays are designed for short-range air-to-air missiles, or SRAMs. The PL-10 is the J-20's primary within-visual range missile. It is an advanced infrared homing missile with high off-bore sight capability. This means it can engage targets far off the aircraft's nose. The deployment mechanism for these side bays is innovative. The missiles are extended outwards on launch rails before firing. This allows the bay doors to remain closed for longer, preserving stealth. The J-20 can therefore engage targets both near and far. While its primary role is air superiority, the J-20 is also expected to have air-to-ground capabilities. Its internal weapons bays could potentially accommodate precision-guided bombs or air-to-surface missiles. Small-diameter bombs like the LS-6 are candidates for internal carriage. This would allow the J-20 to conduct stealthy strike missions against high-value targets. The development of suitable air-to-ground munitions that fit within the J-20's bays is ongoing. This versatility would make the J-20 a more flexible asset for the PL-AF. It could then threaten both air and ground targets effectively. The J-20 also features an internal cannon, likely a single-barrel 23mm or 30mm gun. This provides a last-resort weapon for close-in engagements or strafing ground targets. Furthermore, there are indications that the J-20 might have external hardpoints under its wings. These would allow it to carry additional fuel tanks or a larger weapons load for non-stealthy missions. Using external hardpoints would compromise its stealth, but increase its payload and range. Future weapon developments for the J-20 could include even longer-range missiles or specialized electronic warfare payloads. China is continuously working to enhance the Dragon's talons. Its arsenal makes it a deadly opponent. Section 6. Clash of Titans, J-20 Mighty Dragon vs. F-22 Raptor. Comparing the J-20 Mighty Dragon with the American F-22 Raptor is a common exercise. The F-22 was the world's first operational fifth-generation fighter. It set the benchmark for stealth, supercruise, and integrated avionics. Both aircraft are large, twin-engine stealth fighters, designed primarily for air superiority. In terms of stealth, the F-22 is widely considered to have a very low radar cross-section. Its design benefited from years of research and development. The J-20's stealth capabilities are also significant, though its larger size and canards might present some challenges compared to the F-22's refined shaping. However, the exact RCS values for both are classified. In avionics and sensor fusion, both aircraft are highly advanced. The F-22's APG-77 AESA radar and sophisticated data links were revolutionary when introduced. The J-20's AESA radar and sensor suite are more modern in their design timeline. This could mean the J-20 benefits from newer technology and processing power. However, the F-22 has undergone continuous upgrades to its software and systems. The effectiveness of sensor fusion and pilot interface is crucial for both. The ability to share data seamlessly with other assets known as network-centric warfare is a key strength the US has heavily invested in. China is rapidly developing similar capabilities for the J-20. Kinematic performance is another important comparison point. The F-22 is renowned for its thrust-vectoring nozzles. These allow it to perform impressive post-stall maneuvers and give it exceptional agility. It also has a high thrust-to-weight ratio and excellent supercruise capability with its Pratt & Whitney F119 engines. The J-20, particularly with its current WS-10 engines, may not match the F-22's raw agility or supercruise performance. However, once the more powerful WS-15 engine is fully operational, the J-20's performance envelope is expected to expand significantly. The J-20's design, with its canards, suggests a focus on maneuverability as well. Ultimately, the F-22 Raptor has a proven track record and mature systems. Production of the F-22 ceased in 2011, with 187 operational aircraft built. The J-20 is a newer design, still undergoing development and being produced in larger numbers. The J-20 may leverage more recent technological advancements in certain areas. The F-22 excels in air-to-air combat, its primary design role. The J-20 appears to be designed for similar air dominance missions, but potentially with a greater emphasis on range and strike capability. A true comparison would depend on pilot skill, doctrine, support systems, and the specific combat scenario. Both represent the pinnacle of their nation's aerospace engineering. Section 7 Eastern competitors J-20 Mighty Dragon vs Su-57 Felon. Another key comparison for the J-20 Mighty Dragon is Russia's Sukhoi Su-57 Felon. The Su-57 is also designated as a fifth-generation fighter. It shares some design philosophies with the J-20, such as twin engines and a large airframe. However, there are notable differences. The Su-57's approach to stealth appears to be different from that of the J-20 or F-22. While it incorporates some stealth shaping and radar-absorbent materials, many analysts believe its radar cross-section is larger than that of its American and Chinese counterparts. The Su-57 seems to prioritize supermaneuverability and a powerful sensor suite over all-aspect deep stealth. The Su-57 boasts exceptional agility, a traditional strength of Russian fighters. It features three-dimensional thrust vectoring control on its engines. This allows for very tight turns and unconventional maneuvers. The J-20, while agile due to its canards and control surfaces, does not currently feature thrust vectoring to the same degree, though future engine developments might change this. The Su-57 is also equipped with a diverse sensor suite. This includes its main N036 Bielka ESA radar, side-looking cheek-mounted X-band ESA radars, and an advanced infrared search and track system. This provides excellent situational awareness. In terms of armament, both aircraft can carry a variety of air-to-air and air-to-ground weapons. The Su-57 has internal weapons bays, but their capacity and the range of compatible stealthy munitions are still developing. It can also carry a heavy load on external hardpoints. The J-20's internal bays appear to be larger, particularly the main ventral bay for long-range missiles like the PL-15. The development of advanced, long-range weaponry is crucial for both platforms to maximize their effectiveness. Russia has a strong history of developing potent air-to-air missiles, such as the R-37M. These could be integrated with the Su-57. The development programs for the J-20 and Su-57 have proceeded differently. The J-20 program has seen relatively rapid development and a quicker entry into serial production and service with the PLAAF. The Su-57 program has faced more delays and a slower production ramp-up. The numbers of operational Su-57S are currently much lower than J-20S. This impacts their respective strategic weight. While the Su-57 is a highly capable aircraft with unique strengths in maneuverability and sensor design, the J-20 appears to be a more mature and widely fielded fifth-generation platform at this stage. Both aircraft represent significant achievements for their respective national defense industries. Section 8 From Blueprint to Sky, the J-20's Rapid Development. The development of the J-20 Mighty Dragon was a remarkably swift endeavor. China's ambition to create a fifth-generation fighter was known as Project 718. Several Chinese aircraft manufacturers, Chengdu and Shenyang, submitted proposals. Chengdu Aircraft Industry Group's design was ultimately selected. The program was shrouded in considerable secrecy during its early phases. This secrecy made its first public appearance even more surprising. The first J-20 prototype, designated 2001, made its maiden flight on January 11, 2011. This was a major milestone for China's aviation industry. It demonstrated a significant leap in technological capability. The pace of development continued to be impressive after the first flight. Multiple prototypes and pre-production aircraft followed. Each iteration often featured visible refinements and improvements. These included changes to the airframe shape, sensor apertures, and engine nozzles. This iterative development approach allowed engineers to quickly test and integrate new technologies. The program benefited from substantial national investment and high-level political support. China viewed the J-20 as a critical component of its military modernization. It was also a symbol of the nation's rising technological prowess on the global stage. This focus helped to accelerate its progress. There has been much speculation about how China achieved such rapid development. Some observers suggest that cyber espionage may have played a role in acquiring technical data from other countries' fighter programs. While difficult to confirm definitively, access to foreign research could have helped avoid certain design pitfalls. However, it is also clear that China has made massive indigenous investments in aerospace research, material science and engineering talent. The J-20 is undoubtedly a product of significant domestic innovation and hard work. The ability to integrate complex systems and manage such a large-scale project is a testament to China's growing capabilities. The J-20 officially entered service with the People's Liberation Army Air Force in March 2017. Low-rate initial production had already begun. Since then, production has ramped up significantly. New production batches continue to incorporate enhancements. These include improved engines, refined stealth features, and upgraded avionics. The PLAAF has been actively integrating the J-20 into its operational units. Pilots are developing tactics and doctrines for employing this advanced fighter. The journey from initial blueprint to a fully operational combat aircraft in just over a decade is a notable achievement. It underscores China's determination to become a leading air power. Section 9. Strategic Impact. The Dragon reshapes air power. The J-20 Mighty Dragon holds immense strategic importance for China. Its introduction significantly enhances the capabilities of the People's Liberation Army Air Force. As a fifth-generation stealth fighter, the J-20 provides China with a platform that can challenge the air superiority of other major powers in the region. This is particularly relevant in the context of the Western Pacific. The J-20's combination of stealth, range, and advanced sensors allows it to operate more effectively in contested airspace. It can potentially penetrate sophisticated air defenses and engage high-value targets. This capability changes the strategic calculus for any potential adversary. One key role for the J-20 is likely within China's anti-access/area denial strategy. This strategy aims to deter or prevent foreign military forces from operating near China's territory. The J-20 can act as a long-range interceptor. It can threaten enemy surveillance aircraft, tankers, and command and control platforms. These support aircraft are critical enablers for modern air operations. By holding these assets at risk, the J-20 can complicate an adversary's ability to project power. Its stealth allows it to approach targets with a reduced chance of detection. This makes it a potent tool for shaping the operational environment. The J-20 also serves as a powerful symbol of China's growing military might and technological advancement. Its development and deployment send a clear message about China's ambitions as a global power. It demonstrates that China can produce cutting-edge military hardware domestically. This reduces its reliance on foreign suppliers for high-end defense technology. The J-20 program boosts national pride and encourages further innovation within China's defense industry. The aircraft is frequently showcased in military parades and air shows. This highlights its status as a flagship project for the Chinese military and a source of national prestige. In conclusion, is the J-20 Mighty Dragon the world's top fighter jet? That question is complex. Top fighter can be defined in many ways. The F-22 Raptor still holds a strong claim due to its mature systems and proven performance. However, the J-20 is a rapidly evolving platform. It incorporates newer technologies and is being produced in greater numbers. Its combination of stealth, advanced avionics, long-range missiles, and significant range makes it exceptionally formidable. The J-20 undeniably stands out as one of the most advanced fighter jets operating today. It has firmly established China as a leading player in military aviation. The Mighty Dragon has truly changed the sky.